Hi, I'm Syed on Maths Online. Today's topic is Laplace transform of elementary function. In the previous video, we have seen Laplace transform of the constant L of a to be equals to a by s, and then Laplace transform of the exponential function e power of at to be equals to 1 by s minus of a. In today's video, we are going to learn about Laplace transform of cos hat and Laplace transform of sin hat, two hyperbolic functions. So let us start with finding out the Laplace transform of cos hat. You know the formula for Laplace transform of an exponential function, e power of at to be equals to 1 by s minus of a. So we'll try to express cos hat in the form of an exponential function. So therefore cos hat will be equals to, it is e power of at plus e power of minus of at whole divided by 2. There is the basic formula for cos hat. Let's apply the Laplace transform on both the sides. So L of cos hat, applying the Laplace transform on both the sides, we get Laplace transform of cos hat is equals to Laplace transform of e power of at plus e power of minus of at whole divided by 2. So that will be equals to, you can take that 2 constant outside from the denominator. So 1 by 2 will be taken outside. So we will be left out with Laplace transform of the first function e power of at plus Laplace transform of the second function e power of minus of at. That will be equals to half, as it is. We know Laplace transform of e power of at formula, which is nothing but 1 by s minus of a. So if we try to rewrite it, it becomes 1 by s minus of a plus, similarly you can write down the Laplace transform of e power of minus of at. But the formula that we have is for Laplace transform of e power of plus at, which is 1 by s minus of a. So if you have a negative value, in that case you can rewrite the Laplace transform as L of e power of minus of at will be equals to 1 by s minus of a. So in this case the coefficient of t is minus of a. So if we can write minus of a, which will be equals to 1 by s minus of minus will become plus a, 1 by s plus a. So when you have coefficient of t to be positive value, in that case we will be getting s minus negative sign. But if you have coefficient of t to be negative minus of a, in that case you get plus positive value plus a. So just a technique to remember the formula. So if you rewrite it over here, you will be getting 1 by s plus a. So that will be equals to 1 by 2 as it is. You can take the LCM over here. LCM in this case will be s minus of a into s plus a. You need to just cross multiply the value s plus a. If you cross multiply with 1, you will be getting s plus a. I just cross multiplied that value, s plus a multiplied by 1. So I have got s plus a. In the same way, s minus of a is multiplied by 1, you'll be getting s minus of a. So we get plus s minus of a. Let me just erase the arrow marks over here. So it is s minus of a, that is 1 divided by s plus a. So here plus a and minus of a will cancel out. So we get 1 by 2 as it is. S plus s will become 2s divided by, the denominator is in the form of a minus b into a plus b, which will be written as a square minus b square. So therefore you can write it as s square minus of a square. You can cancel out the 2 in the numerator and 2 in the denominator. So we'll be left out with s by s square minus of a square. Hence we got the Laplace transform of coshat will be equals to s by s square minus of a square. So now let us find out the Laplace transform of sinhat. To find Laplace transform of sinhat. So we got the basic formula for sinhat to be equals to e power of at minus of e power of minus of at whole divided by 2. Apply Laplace transform on both the sides. So Laplace transform sinhat will be equals to, apply Laplace transform on the right hand side. Laplace transform of e power of at minus e power of minus of at whole divided by 2. We will take 1 by 2 outside, and we have Laplace transform of e power of at and minus of Laplace transform of e power of minus of at. So that will be equals to 1 by 2 times of, we know the Laplace transform of e power of at to be 1 by s minus of a, and minus of the Laplace transform of e power of minus at can be written as 1 by s plus a. So that can be further written as 1 by 2 times of. So we can take the LCM. In this case the LCM will be s minus of a into s plus a. And once again we'll try to just cross multiply. 1 into s plus a will be s plus a. Here you have negative sign common there. So we'll take negative sign common, multiply s minus a with 1. You'll be getting s minus of a. So in this case plus s and minus of s will cancel out. You will be getting it as 1 by 2 times of, it is a minus of minus will become plus a. So that will be plus a. So you will be getting a plus a divided by, it is a minus b, a plus b form. So a square minus b square will be nothing but s square minus of a square. So which will be equals to 1 by 2 as it is. A plus a will be 2a divided by s square minus of a square. So 2 and 2 will cancel out over here from the numerator and denominator. Will be left out with a by s square minus of a square, which is the Laplace transform of sinhat. Next result is to find out the Laplace transform of the trigonometric function cosat. So we'll try to use the basic formula for Laplace transform. It is L of f of t is nothing but integral of 0 to infinity e power of minus of st f of t into dt. So this definition I have already given you in the previous video. You can watch my previous video to know this definition. So f of t in this case is cos at. So I'll just replace f of t as cos at. So we get L of cos of at. So the value of f of t is cos at. Right hand side you have integral 0 to infinity e power of minus of st. F of t value is cos at into dt. So we know the basic formula for integral of e power of ax cos bx into dx. So we'll try to use this formula to solve the above result. So its formula is e power of ax divided by a square plus b square into it is a cos bx plus b sin bx. That is the basic formula for integral of e power of ax cos bx into dx. So if you try to compare the coefficients in this case, your value of a over here is minus of s. The value of x is nothing but t, and value of b is nothing but a. So a value over here is minus of s. Your value of x is nothing but t. Your value of b is nothing but a. So replace this value back in the given formula. So we get Laplace transform of cos at will be equals to, so we'll try to use the formula e power of a value is minus of s, x value is t divided by a value is minus of s, so we'll be getting minus of s whole square plus b value is a, so we'll be getting a square. It's times of a value is minus of s cos of b value is a, x value is t plus b value is a sine of b value is a, x value is t, and limit values over here nothing but 0 to infinity. So we'll try to replace those limit values, which will be t is equals to 0 to infinity. So when you apply the upper limit value for t, which is infinity, so we'll be getting infinity into s will be infinity itself. So we get e power of minus of infinity, which will be the upper limit value. So we know that e power of minus of infinity will be equals to 0. So we'll directly replace the value of e power of minus infinity as 0, and 0 into anything will be 0 itself. So the whole of the upper limit value will become equals to 0. So this entire value will be 0. The upper limit value is 0. So it is 0 upper limit value. Just erase that one. then minus of the lower limit value. So the lower limit value for t will be 0, so 0 into s will be 0 itself, divided by minus of s whole square will become plus s square plus a square, is times of minus s cos of t is 0, 0 into a will be 0 itself, so we'll be getting cos of 0 plus a into, it is sine of t is 0, 0 into a will be 0. So we applied the lower limit value. So if you try to rewrite 0, you can just ignore, we will be getting minus e power of 0 will be 1 divided by s square plus a square, it's times of, so we know the value of cos of 0, cos of 0 is 1 and sine of 0 will be 0. Cos of 0 is 1, 1 into minus of s will be minus of s, plus sine 0 is 0, 0 into a will be 0 itself. So we just try to multiply, minus of minus will become plus s divided by s square plus a square. So we have got the Laplace transform of cos at will be nothing but s by s square plus a square. Let us move on to the next result to find out the Laplace transform of sin at. So once again we'll try to use the basic formula for Laplace transform, L of f of t to be equals to integral 0 to infinity e power of minus of st f of t into dt. So here we know that the value of f of t is nothing but sin at. So in place of f of t, replace that by sin at. So we'll be getting integral 0 to infinity e power of minus of st, the value of f of t is sin at into dt. So that can be further written as, you know the formula for integral e power of ax sin bx into dx, which will be equals to e power of ax by a square plus b square. It is times of a sin of bx minus b cos of bx. That's the basic formula for integral e power of ax sin bx into dx. So once again try to compare the values of a, x and b. The value of a will be minus of s, the value of x will be t, and the value of b will be equals to a. So let us try to plug in these values in the formula. So we get Laplace transform of sin at will be equals to e power of a value is minus of s, x value is t, divided by the value of a is minus s, so we will be getting minus of s whole square plus the value of b is a, so we will get a square is times of a value is minus of s into sine of b value is a, x value is t, minus of b value is a, cos of b value is a, x value is t, and we know the limit values over here. Limit values are t is equals to 0 to infinity. So let us apply the upper and lower limit values over here. An upper limit value for infinity, e power of minus of infinity will be 0. So the entire first term will become equals to 0. So the upper limit value infinity will make the whole term to be equals to 0. So upper limit becomes equals to 0. So upper limit is 0. Let me just erase that line. Then write down the lower limit value. Minus of the lower limit value for t will be 0. So e power of t is 0. 0 into anything will be 0 itself. So e power of 0 divided by minus of s whole square will be s square plus a square. It is times of minus of s. It is sine of t is 0. 0 into a will be 0. Minus of a into cos of t is 0. 0 into a will be 0. So you get cos of 0. So we know the value of sine 0 to be equals to 0, and cos of 0 value, we know its value is 1. So if you try to simplify it, minus as it is, e power of 0 is 1 divided by s square plus a square times of sine 0 is 0. 0 into anything will be 0 itself. First term is 0 minus cos 0 is 1. So 1 into a will be a. So just to multiply it, minus of minus will become positive over here. So we'll be getting plus a divided by s square plus a square. So hence we got Laplace transform of sine at to be equals to a by s square plus a square. So that's all I have for today. Thank you.